Welcome to video 2 of section 25, linear modeling. We are together here on page 225. We're going to jump right into some working with linear models. So there's a linear relationship between degrees Fahrenheit and degrees Celsius. Now when they tell you there's a linear relationship, that means if you graph this, it'll be a straight line. So freezing for water is 32 degrees Fahrenheit and 0 degrees Celsius, and boiling point for water is 212 degrees Fahrenheit and 100 degrees Celsius. So parts A and B, we just want to write ordered pairs. So I do challenge you for this problem to hit pause and just try to do A through D here and see if that works for you, and then come back and watch it. All right, so the freezing point of water is an ordered pair. Well, notice that Celsius comes first. So the freezing point in Celsius is 0, and in Fahrenheit it's 32. So there's my ordered pair. And then boiling, if Celsius is first, we have 100, and Fahrenheit is 212. So there are my ordered pairs, and that's very important that you find ordered pairs because we need them to find slope. So let's use those values to find the slope, remembering that the slope is change in y over change in x, which we can say is y2 minus y1 over x2 minus x1. So if my two ordered pairs, 0, 32, and 100, 212, I'm going to go ahead and say x1, y1, x2, y2, and I'm going to go with 212 minus 32 over 100 minus 0. Simplified out, I get 180 over 10. Oops, excuse me, over 100. Forgot a 0. You can go ahead and just divide that and get an answer of 1.8. That's fine. Or you can say, well, if I just reduce this fraction, right, I can cut off a 0 and get 18 over 10, and then divide them by 2, and I get 9/5. Either one of these is totally fine in terms of the slope. Now, mathematically, I prefer 9/5 because slope is meant to be a fraction. So the 9, right, is the y values. The y values represent Fahrenheit. So for every 9 degrees increase in Fahrenheit, you get a 5 degrees increase in Celsius, right? It gives you a better understanding of what it stands for and what it means. So I prefer fractions, but that's me. And in letter D, let's go ahead and write a model. So y equals, we know our slope, and I'm going to go ahead and use the fraction because it's my video, and that's what I like. And then our slope, the y-intercept, remember, is your starting point. So when the x value is 0, what's y? Well, look here. When the x value is 0, y is 32. So my y-intercept is a positive 32. And now we can use our two ordered pairs to graph this. We know that one ordered pair is 0, 32, and the other is 100, 212. So if I go to 0, 32 and I plot a point, and then I go 100, 212 and I plot a point, and then very nicely with the tip of my finger I can draw my line. So you can see as Celsius increases, so does Fahrenheit, right? We have a positive slope. All right, moving on to number 2. Leasing a particular car costs $850 plus a monthly fee of $225. I want you to, again, hit pause and try to answer the rest of question 2, and then come back and watch the explanation. So in letter A, what is the y, the dependent variable, and what is the unit measure of y? Well, you might think, well, this is kind of hard. What is x, the independent variable? Well, I don't know. So, when you're thinking about this, it might be easier to say, okay, what are we really talking about here? I've got a $850 plus a monthly fee. Now, the monthly fee, right, that happens all the time. That right there, covered in color, that is your constant change. So the constant change is going to be your slope. And when you lease it, if it costs $850 initially, right, there's your y-intercept. So I kind of am jumping ahead. I'm going to come back and hit A and B, but I just found my y-intercept to be $850, and my slope is $225. And it's increasing, right? You're paying it every month, so that value is going up. So I can pretty easily model this by saying 225x plus 850. What is this talking about? Well, it's talking about the price of leasing this car, right? So sometimes I think it's easier to write the equation first, depending on what information they give you, and then go back and identify, what do these things mean? So I'm going to go back now and say, okay, I'm going to think about cleaning up this problem here. I have y equals 225x plus 850. And I know that I'm paying 225 per month. So x is the number of months that I'm leasing this car, because for every month I owe $225. And the dependent variable would be the total cost of leasing. Because when you look at the right side of this equation, I've got the monthly cost plus the initial fee. So the initial fee plus the monthly cost together is going to give you the total cost of leasing. And the total cost is going to depend on how many months you actually lease that car, right? If you only lease it for 2 months, your cost is going to be considerably less than if you lease it for 24 months. So something, right? We always want to keep in mind what depends on what. All right, so let's get down to letter F now. How much would it cost to lease the car for 6 months? Well, months is X, so Y equals 225 times 6 plus the initial cost of 850. Wow, that's sloppy. 850, there we go. Okay, so when I do the math, 225 times 6 gives me 1350 plus my starting cost of 850. So a 6-month lease will cost me $2,200. Right, so just in case you wondered. And then I go to letter G and say, well, how many months could you lease the car if your budget was $3,800? Okay, so again, remember that your equation here, now we are given our budget. Well, budget is the total cost, so that value is going to go over here. Okay, and now I do some excellent math skills, remembering again the equation, you got to do the same to both sides, so I subtract 850 from each side. And I get 225x equals 2950, and then I divide both sides by 225. Now, when you do that, you get x equals 13.11 months. Is a car company going to say, hey, you go ahead and keep that for 0.11 months? No. You do total months. Now, can I round that up to 14 months? No. You can't pay for 14 months. You can only pay for 13. So your answer to this question is 13 months. That's how many months you can lease this car. All right, moving on to page 226. Again, I want you to hit pause. I want you to do as much of 226 as you can, and then come back and watch the explanation of them. So number 3, to rent time on a computer with internet access at a local copy shop costs an initial fee of $5. There's my y-intercept. And $1.25 for every hour. There's my slope. So when I set up my linear model, y equals $1.25 per hour plus 5. So x represents number of hours, y represents my total cost. So how much would 8 hours of use cost? Well, that goes in for x. So y equals 1.25 times 8 plus 5. 1.25 times 8 is 10. So this is going to cost me $15 to use the computer for 8 hours. Now, if you go back to, or go to letter C, how many hours can you rent it if you only have $12? So now your 12 is going to go in for y, because that's your total budget. So again, I got to do my lovely math, subtract 5 from each side, and I get 7 is 1.25x. Divide both sides by 1.25, and you get a value of 5.6 hours. Now, I don't know anything about renting computers at a copy shop, so they might let you do partial hours, perhaps. They might not. If they say you have to do full hours, then you can afford 5 hours. But if they allow partials, then you can do 5.6. So totally depends on, I guess, the coffee shop that you're at. Number 4, in 1980, a pack of cigarettes cost $1 on average. In 2000, the average cost was $3. Use this information to estimate the cost of a pack of cigarettes today. Okay, so this gives us very little information in terms of how to write the equation. So the first thing I'm going to do is say, well, 1980 is the oldest year I have. So I'm going to say, let's let 1980 mean x equals 0. So I have an ordered pair of 0, 1. Right, because that's 1980 with $1. So then 2000, that's 20 years later, so x would be 20. So then I have an ordered pair of 20 3, because in 2000 the price was 3. Now what can you do? Well, if you have 2 points, you can find the slope. So I can now say 3 minus 1 over 20 minus 0 gives me 2 over 20, or 1/10. Here's my slope. Good, I do have more room. So I can write the equation, y equals 1/10 x. What did I start with? X value of 0, so my y-intercept is 1. So I now have a model for the price of cigarettes going up, right? So for every, they go up $1 for every 10 years is what our slope tells us. So it does say, estimate the cost of a pack of cigarettes today. Okay, so today is 2015. So if 1980 was x is 0, then 2015 has an x value of 35. So I can use my equation, y equals 1/10 x plus 1, and I'm going to plug in 35 for x. So 1/10 times 35 plus 1. So when you do this, you get 3.5 plus 1. A pack of cigarettes today, on average, would be $4.50 if this model held true. All right, so sometimes you've got to take the information they give you and you have to put it into words or ordered pairs or something that makes sense in terms of mathematics. And number 5, I don't know how you can't be happy when you're talking about the Happy Widget Company. They have a fixed cost of $1,500 a day, and then a variable cost of $125 for each widget. So if you think about, if we're talking about one day, we have a $1,500 a day, so that's for electricity, water, blah, 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 whatever. And then each widget is $1.25, so that's my slope. Because if I only make one widget, it's only cost me $1.25. If I make 10 widgets, it's $12.50, right? So that cost changes depending on how many widgets. So now I can use that information. My linear model is 125x plus 1,500. And what do x and y represent? Well, x is the number of widgets, as I was just talking about. If you only sell 2, it's only $2.50, right? So x is the number of widgets, and y is the total daily cost. And I say daily because our fixed cost is $1,500 per day. Let me change colors for effect here, per day. So we are talking about in one day, we have a fixed cost and we are producing widgets. So that lets us know a daily cost. All right, let's go to letter B. How much does it cost to produce 300 widgets? Well, in our equation, x is the widget. So let's plug in 300 for x and do some math, right? Makes everybody happy. And we end up with $1,875. So it'll cost you $1,875 to produce 300 widgets. Letter C, how many widgets can they produce for 2040? Well, that's going to be your y value. So again, we say, let's do the math. The equal sign cuts it in half. We got to do the same thing to both sides. So I subtract 1,500, and 1.25x equals 540. Divide both sides by 125, and we get 432. So you can produce 432 widgets in that amount of time. Okay. Going ahead, now we have a graph. Well, you've already found a lot of things, right? We know that if we don't make any widgets, it's going to cost us $1,500, right? That's our, whoops, that's our y-intercept. Move my graph, changes everything. 1,500. Okay. Now, we did 300, right? In part B, we know that 300 is 1,875. So it's just less than 1,900. And you really should maybe pick another one. If you pick 200, if x is 200, y gives you a value of 1,750. So 1,750, so 2 is 1,750. And if you pick x is 100, you get 1,625 for y. So I just picked a couple more points, and now you can see I have a pretty nice line. So I can start at 1,500 and draw through my points. And notice we have linear because it depends on the number of widgets of what you're going to get. All right, moving on to the last page, number 6. Go ahead and just try number 6 and then stop, and then come back and watch it. So Dale takes a trip and finds that he was able to drive 350 miles in 7 hours. Set up a linear model that can be used to find how many miles Dale has driven given how many hours he's been on the road. Well, this is a little bit difficult because they give us total miles and total hours. Well, when you're using slope, right, we might want that to be miles per 1 hour. So if you think about 350 miles in 7 hours, well, if you just reduce that, you end up with 50 miles in 1 hour. So our slope is 50. So set up a linear model. If y is the number of miles driven and he can drive 50 miles an hour, then, so x is the number of hours and y is total miles. So it works for the information they gave us. If we would plug 7 in for x, 50 times 7 is 350, then his total miles is 350. So sometimes it helps to like maybe write an equation and think about what you have, use the information they give you to see if that equation makes sense. Now, what does the slope of the model represent? Well, our slope was 50, and it represents miles per hour. And what assumptions does your model make? And this is true about all models. The assumption is that we stay constant. So if you're driving for 7 hours, you drive 50 miles an hour consistently, 7 hours, no braking, no speeding up, no stopping, no nothing. How realistic is that? It's not, right? There are stoplights. You have to get gas. You might have to stop to go to the bathroom. There might be traffic. Somebody might have cut you off. You might have to pass a semi, right? There's a million reasons of why you can't go 50 miles an hour for 7 straight hours. And really, why would you want to? We are skipping number 7, and we are going to number 8. So number 8 on page 227, a cell phone plan charges a flat rate of $20 plus 50 cents for each kilobyte of data each month. I think it's kilobyte, right? KB. So create a little linear model. Well, when you're looking at what they give you, flat rate, it doesn't change. So that's your y-intercept. Plus 50 cents for each kilobyte. There's your slope because it changes. So the number of kilobytes will affect your overall payment. Okay, so your model, y equals my slope times x plus my flat rate. So x represents the number of kilobytes, right, because they're each 50 cents. And then y is the total cost of the plan. Have you noticed, this is for the month, have you noticed that the majority of the time when I talk about y, I usually use the word total because we are talking about, putting it all together. So when you think about a total, that's usually your y value. That's your dependent variable. All right, how much will the bill be with a 350 kilobyte of data usage in a given month? Well, we've got our formula, 0.50x plus 20, and 350 kilobytes, right? That'll go in for x. So 0.50 times 350 plus 20. And at this point, I start to hyperventilate because we have 175 plus 20. Your bill is $195. And I feel like my bill is high enough. That would just put me over the edge, I think. And let's pretend, going the other direction, you got a bill for $32, so you want to figure out how many kilobytes you used. So $32 is the end, 0.5x plus your flat rate. So again, your equal sign splits it in half. Let's subtract 20 from both sides. 0.5x equals 12, and I'm going to divide both sides by 0.5. So I used 24 kilobytes of data to get that. All right, and that ends lesson 25, linear modeling. Thanks for playing.